Perfect. Thank you so much for the introduction. And now you should all be seeing my screen. Hopefully that's working for you, and hopefully you can hear me at home. Um, Hi, everyone. My name is John. Thank you for joining me today. Also, before we get started, I'm really sad that I can't be joining you all in Las Vegas this year, hence the background. The high today is only like 50 degrees compared to like 80 in Las Vegas, so that's a bummer, but we're here. So thank you again for joining me today.
That's very
Um,
that's very good thing. Thanks, John. Maybe next year. See.
Maybe next year, hopefully. Okay, so today I'm going to be talking about KickVR, and it's a self-defense virtual reality simulation to teach self-defense skills. And I worked on this with my mentor, Dr. Alex Rede. And so I'll be giving you a brief background on how this project came up, as well as the goal for what this project is supposed to do, as well as what users who want to use this software will need in terms of hardware and software. And then I'll give you like a short walkthrough of what the simulation would look like if you were to put on a virtual reality headset. And then at the very end, we'll talk about optimizations. And this is basically future work where we hope this simulation will go after this point. So without further ado, at the very beginning, let me back up. I'm a Central Michigan University student, and this will be my 4th year attending school at the university. And throughout my tenure here, I believe we've had 2 shootings on campus. There are multiple organizations on campus that are created to empower students to speak up about the experiences that they've been having on campus, as well as a new coalition between students, faculty, and police officers in order to talk about crime and ways in which the community can improve. And so I've realized there's been a lot of crime in this campus community, and that it's not an isolated event. At my university specifically, there are 300 students each academic year who are victims of violence and crime. And I'm sure there are many more who do not report because of possible retribution as well. So that could definitely be higher. And so we saw this societal ill, and we saw that we have some tools in order to empower folks in the community to learn self-defense and to defend themselves from these potential situations. And so this led us to create KickVR. And so it really has a real world impact, and it empowers those populations to defend themselves so they don't have to rely on institutional investigations and other forms of bureaucracy to protect them. And so I don't have any self-defense experience, and my colleagues that I worked on this project with, including Dr. Rede, didn't have self-defense experience. And so we thought the first place we should go in order to learn self-defense and figure out where these high frequently and like commonly occurred experiences of crime in the community, where those happen. And so we went to the Mount Pleasant Police Department, and I spoke to an officer there who says that all of their police officers learn Krav Maga, which is hand-to-hand self-defense technique and ideology. And they also use that to teach folks in the community, including what you see on your screen. That's a woman from a sorority on campus, to teach vulnerable folks in the community how to learn self-defense. And so we talked to this individual on what skills should be learned, as well as areas in the community which were common areas of violence. And using all of this information, we decided and we laid out in like a storyboard exactly what the simulation would look like, and how we would teach user self-defense, because the intention was to create this simulation and give it to the police officers and have them run virtual reality headsets in their facility, so that they could they could be out in the community fighting crime, and there could just be like one person watching folks come in and do the simulation. And so the reason why this class would be successful is because there's other classes in the nation, including one that's had over 60,000 graduates. And out of those 60,000, 97% were able to successfully defend themselves when some sort of violence or some sort of crime occurred, whether that be through conflict resolution, and talking someone down, or self-defense and having to actually use hand-to-hand combat. And so our ultimate goal was to create a realistic simulation with a user-friendly guide to teach users self-defense. At the end of the day, that's what we wanted to build, and we wanted to use those different characteristics like Krav Maga to do that in this simulation. And so the hardware components to run this simulation, we use the original Oculus Rift, which includes having 2 Oculus sensors placed around the room to create a play space, a virtual play space. And that Oculus Rift headset would also need to be connected to a Windows PC. There are some now that do not have to be connected to a Windows PC, and we'll get to that later. And also something that is really cool is that we used the Leap Motion sensor to get rid of the Oculus Rift touch controllers, so that it would be mounted to the front of the headset and users could see their hands without having to use hand controllers in the virtual space, to make it as realistic as possible. So to give you a look as to what the user would see when they put on the headset, after the play space is calibrated, as well as the motion tracking with the Leap Motion sensor, the user would be put into the KickVR virtual hub, which is what you're seeing in front of you. And so the hands that you see, those are the hands that come in via the Leap Motion controller, and all of the rest of the environmental aspects that you see are through the headset using Unity. And so users can select any training modules that they want. Specifically, the one that you're seeing, they could learn like the closed hand strike, for example. And when they choose which module and which training module they want to do, they would go into a practice environment so that they can learn the skill in a safe spot. And one thing we talked to the police officer about was that folks who learn self-defense are typically vulnerable populations. And so we want to make the environment that they learn the skills in a safe environment. And so having a gym environment would be more safe than having some sort of at-home environment or at a police station. And so that's why we're using the visual aspects you see. And so in this practice environment, there are multiple characteristics that you have here. So right in front of the hands is an NPC. This is what the user would be using their skills on. So say we chose the closed hand strike, you would be practicing your closed hand strike on this NPC. And so the NPC just stands there. They don't have any animations that move them. This is supposed to be a control environment. Behind the NPC is a video of an expert actually doing the movements. That is a 2D video. And so we also have an NPC to the left, which also does the animation of the skill you are learning. One more thing to point out is that there's a health bar at the top left corner, and that is user health. In this scenario, user health would not decrease. But one difficulty we did have is that it's only in the left-hand side of the screen, because if you put it on both eyes, your brain would try and make up the difference and put it like in the middle of your vision. And so it's only in the left eye of the virtual reality headset. And so then the user would use the hand tracking and do a thumbs up to put themselves into the application scenario. And so there are 3 application scenarios so far. And these are what the police officers determined were the most common occurrences of violence. On the top left, you have a bar scenario. On the top right, you have walking home. This is supposed to represent the street in which most of the fraternities and sororities are, and in the Mount Pleasant community, as well as at the bottom, that's a parking lot. So a common occurrence is for violence to occur for folks who are walking back to their car, either from like Walmart, some sort of superstore, or like a library for the campus community. And so the application scenario would end when the user defeats the NPC and makes their health go down, or the NPC defeats the user and the user doesn't have health left. And so this is done through hitboxes on the NPC and through the hands of the user. And specifically for the user, if they were to hit the head, that's one of the most vulnerable parts on the human body. And that's represented by doing more damage to that spot compared to like the chest or the arms of the NPC. And so at the very end, regardless if the user was successful in defending themselves, they would be sent to a summary scene, which you can see here, and it will tell them all of the hits that they did over the course of the application scenario. And so in the future, we think it would be best suited for the simulation, since we're focused on realism, to develop this in Unreal Engine. They have, as you can see in on the left, that's one of the NPCs in Unity. But in Unreal Engine, they have photorealistic rendering and a built-in material editor, so you can edit materials and edit the environment in real time. But the expense is that we have to redevelop this all in C++ again. So we would like that to happen in the future. But one of the biggest things that happened in the past like year or two is that the Oculus Rift now has built-in motion tracking. So instead of the Leap motion controller being mounted on the front of the Oculus Rift, it's built in through the sensors you can see on the Oculus Rift S and the Quest 2. And so you would be able to reduce latency as well as load times by not having to have 2 different pieces of hardware working at the same time. And there are some other broad implications that we weren't able to research because of the current coronavirus pandemic. We had IRB approval to study humans and their interaction with VR and how that affects skill development as well as enjoyment and motion sickness, but we never got the chance to do that. But some other broad implications, especially for the coronavirus pandemic, would be being able to put on a $300 Oculus Quest 2 and being able to be put into a virtual hub with your peers to learn something with hand tracking, such as sign language. I think that'd be a really cool extension of this project and a bigger application of this. One other thing that we thought might be great to use in the future is Microsoft Connect in order to develop other skills like elbow strikes, knee strikes, kicks, as well as like grappling from behind is very common as well, from what we heard from the police officers. And this tracks, I believe it's 12 million points in space within 66 milliseconds. I think it's every 66 milliseconds. And so it's much more accurate than 10 years ago when this came with Xbox 360s and Xbox Ones. And so we think there are a lot of applications for this too. But again, we never got the time to test this out and actually research if it's beneficial for commercial use. So yeah, that's all I have for you today. I hope I stayed on time. But yeah, I'd love if y'all have any questions. I would love to field those now.
Okay, thank you, John, for your wonderful talk. Okay, so any questions from the audience?
I don't have a question. Actually, I want to make some comments. Okay.
Go ahead.
Sure.
So first of all, John, great talk. I mean, I've been impressed. I think this is very, very fundable. You can get funds from if you apply to the right sources. Good project. Also, you presented very well. I think you've been on time also, which is a sign of maturity. And based on everything, if I may, I'm maybe one of I'm one of Dr. Wu's co-advisor, and I'm your advisor's advisor. I used to be, right? So I recommend that you go for grad studies. You are so good. You'd be perfect for that. That's it.
Thank you so much. I appreciate it. It means a lot.
Okay, so thank you, Dr. Dasalu. Okay, so I do have a question here. You said that you're using leap motion here to track the fingers instead of using controller here, right?
Correct.
Do you need to stay very close to the leap motion to track your fingers, or like because you are doing some training here, right? If the user move the fist away from the leap motion too far away, are you going to lose the tracking?
Yeah, that's a great question. I'm going to back up to the slide where the leap motion controller is.
Okay.
And from our experience with this leap motion controller, it has a range of around 2 to 3 feet, which is sufficient for what we're doing. But also, if you extend too far, the tracking won't work. And some ways that we've gotten around that were to put some inertia values into the hits that users do in case their hands do go off the screen. So say if you were punching and extending really far, instead of not registering a hit at all, it would calculate the inertia value that your hand is going with, like the velocity. And that would be sufficient for understanding if it was a visual bug or if it was a limitation of the leap motion controller. But we do hope that that will be fixed with the Oculus Rift S and the Oculus Quest 2. But it looks like the leap motion controller is mostly used when it's not on a virtual reality headset and it's like a standalone on like a monitor looking down at your hands. There are some common examples of using the leap motion controller to type on a keyboard that's not there. And so there are definitely difficulties between having the leap motion controller see your hands in front of you, as well as it moving with your head when you do movements. So good question. Thank you.
Okay, one possible solution here is, as you mentioned, you may consider to use Oculus Quest. The second version is coming, I think just recently, a few, like just either last week, I think last week is published, Oculus Quest 2, and it supports the finger tracking things, even though it's not very accurate, at least not for Quest 1, we tried that already, it's not very accurate. It's just to show you basic promising function, but it's not accurate. Hopefully, Oculus Quest 2 will have a better performance. Okay. Good.
Dr. Wu, we should probably talk sometime about the new pair of gloves that I've got in the lab.
You got a grab?
One of my grad students, Justice Colby, has them at home now, which also do all the finger movements and tracking of them. He's really liking them.
Okay, cool.
Because he really thinks he can do some sign language stuff with it too.
Yeah. That is very promising. Yeah, let's talk after.
Dr. Rade, take some notes too. We'd love to order some of those as well.
Yep. But just pay attention to the security issue. Okay. You must log in with your Facebook or you cannot use it. So that is not quite. cataract.
Dr. Rede should be able to provide the funding. He's pretty good at that.
We'll talk afterwards, Dr. Rede.